Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm working on a project for one of my viewers again, and this is an interesting little project I think we're going to be doing here today. This is a fence off of a Wadkin table saw woodworking machine. Wadkin was an English maker of woodworking machinery. They made very, very high quality tools, probably some of the highest quality woodworking machines that were ever built. And the fence on this saw has just got all kinds of really fine adjustments, some very accurate adjustments, unlike a lot of fences you see, a lot of cast iron here. But unfortunately, over time, there was some wear in this particular piece, and that's what we want to work on today, is try to get that fixed. I'm going to zoom you in here, show you this fence, because it's really kind of interesting the way it's designed, show you what we got to do, and then we're going to get started on this project. So here's the fence, and you can see there's lots of things going on here. First off, this is the part that the wood actually slides on, and it's got adjustments in here where you can adjust this thing forward and reverse depending on how you want to set it up. You just loosen a couple of bolts in here and you can do that. It's got this nifty little angle feature on here. Here we go. You can adjust this to different angles. So if you're cutting an angle, if you adjust it to 45, you can actually slide this down so that it goes up against the bottom. So it's got adjustments built in for that. Let's see, we'll go ahead and snug it back down at 0 here. But this is really one of the cool features here. This is a fine adjust. So basically what happens is that this piece here kind of locks down onto the table. There's this adjustment here. You tighten this up, and it just there's a dovetail, and it tightens this piece in. But then you can fine adjust the fence, move it in and out by turning the knob on the end. And of course, you can lock it down right here. And this is the area that we're going to be doing some repairs. Let me flip it up and show you that. So if you look on this bottom part, there's a key. It's actually machined into the casting, and this slides in a slot on the table of the table saw, and that's what allows this thing to adjust in and out. You can see when you move this part here, that's where you do your fine adjust. The slot here fits down into a dovetail that's milled into the table. This part on the top just glides in that dovetail, but then you got this dovetail key here. This is where you can tighten it up in there. This part gets attached nice and tight, and the rest of this can float back and forth. The problem he's got is that over the years of just sliding this thing back and forth in the machine, the key that is machined into this piece here has gotten thinner and thinner and thinner. It's worn on the sides, and now it's actually there's a little bit of rock in this thing when it goes in there. He wants to get that out of it and make it where it's nice and tight. So the game plan is today, what we're going to be doing is we're going to be milling these slots completely off, actually milling a slot into the piece, and then I'm going to be putting some keys in here that can be removed and replaced as this wears again over time. And he has opted that instead of using steel or cast iron, he wants to use bronze in these, and this is based on, I think, on some repairs that some other people have done. He sent me some bronze material here to make those key plugs out of. So two things, we'll have to mill this out, get this piece lined up on the mill machine, get this milled out so that it's parallel, everything's nice and parallel or square to the fence, and mill that slot out, and then we'll have to machine some keys, and we'll just put them in place with a couple of screws so that they can be taken out, removed, and replaced again as needed. So let's get this part disassembled. The biggest challenge I see on this job is going to be work holding. This casting is going to be a little bit awkward to set up on the milling machine because there's really not any flat surfaces and parallel surfaces. So it's going to require some jacking and some shimming, and I don't know, we're just going to have to get creative over there to figure out how to do that, but no problem, we'll get it done. Let's start taking her apart. Let's see if we can just unscrew this piece and it come out. I think it will. And I'm gonna have to, I was hoping I could leave this piece in here, but looks like I'm gonna have to take it out. So all right, this looks like the small end. There it goes. All right, there we go. Kind of put all this back together. Keep track of our parts, and now that piece comes out. All right, up here, should be able to unscrew this part. So there are two pins holding this in, and there's set screws on the top. There's actually holes to punch them out. I'm hoping that these are going to come out fairly easily. You don't ever know. Okay, that set screw was not too bad. And I've got a long punch here. This is what I'm really concerned about. I don't know when the last time these pins have been out. And it looks like it's coming. That's good. I'm messing up his paint job, but he's gonna have to deal with it. All right, that pin is out. Let's do the other side here. And that one's coming with no problem as well. That's good. All right, that was what I was concerned was going to be a pain, but turned out to be not too bad. So now I've got this casting loose, and challenge is we got to set this thing up on the milling machine, that side up. All right, I think I'm pretty happy with my setup over here, and let me just kind of let you know what we did. I put this boss in the vise. It actually has machine surfaces on both sides. I had trimmed my vise up, so that got me pretty square in this direction. I had to do a little bit of bumping to get it exactly right, but that got me real close. And then down here, I put a planer jack up underneath this, and then just took a long stud and pulled it down tight. So, and it's down on the bottom in the vise here as well. So it's nice and secure. The next thing I had to do was to get this thing, make sure it was aligned in all directions. That proved to be challenging. And the reason is that this surface on the bottom has got some wear in it just from years of use, and it's not perfectly flat. And when I say not perfectly flat, it's within a couple of thousandths, but it really made indicating this difficult. From the standpoint of a woodworking machine, a couple of thousandths is a mile. So there's, I'm not worried about it being, so far out of whack it's going to really be of any consequence. But like, for example, I went across this surface in the back because I could sweep it without having to raise up over these here. And it was lower on both ends and higher in the middle. In other words, it had been kind of rocking. So I basically just got the two ends to zero, and that's as good as I can do. It's really not going to matter because we're on such a small area here in the middle. 2/1000ths out of whack this way on such a small area here in the middle. I mean, it's going to be less than a thou, so I'm not worried about that. I also found that by indicating on the long surfaces here, there was some up and down in it. I ended up indicating on the bottom of these keys where I've got my indicator right now, because that's actually a surface that has seen very little wear. It really hasn't rubbed up against anything very much. So that's pretty much an original surface, and you can actually see the mill marks in there. And again, when you got a precision indicator on here and you can visually see the mill marks in there, you got a thou or two of bouncing around just going over the mill marks. So I've got it from end to end again within about it's within about a thou right now, so I'm happy with that. And to check the squareness, I just ran an indicator along the edge of this key, and I did it on both sides and kind of averaged it out, because again, I knew that's the whole reason we're doing this job, is because this surface is worn. But that's the best surface I've got to actually indicate in the squareness, and that's going to determine how square the fence is to the machine. And again, it's within a couple of thou, and in the world of woodworking, I think that that's going to be probably more accurate than it was when it left the factory. I'm happy with it. I think it's a nice sturdy setup. I think we're ready to go, so I'm going to go ahead and get this thing ready. We're going to go ahead and mill this old key out of there and mill a slot down so we can put a new key in. I think we're about ready to start milling this. I have got a 9/16 inch end mill in here. That is the width of this slot, or this key that we're going to be putting in here. I measured this 1/8 of an inch high. I think what I'm going to do is we'll go twice that depth, so it'll be 1/4 of an inch deep, and that should give us plenty of room to register the new key and still have the proper amount sticking up. So I think I've got it pretty much lined up in this direction. Let's fire up the phase converter. The old American rotary phase converter is making power. I'm gonna put that in higher gear. In a second, let's change speeds here. All right. I'm slowly raising the table up. All right, we are touching right there. Just barely touching, but we are touching. Got my Z-axis, my height zeroed out now on the digital readout. We'll do about a 50 thousandths pass across there. We're just going to make that old piece go away. Go another 50 thousandths on my depth. All right, we're 100 thousandths deep now. Going a total of 250. Let me do another 50. Come back across. Last pass on this side. All right, our new slot has been cut on that side, and we need to go to the other side and get that one done. All right, I think we've got the milling done on this part. Well, guys, I'm over here at the horizontal mill, and the reason that I'm at the horizontal mill is because I made a mistake, and this is how we're gonna get around our mistake. So I set up the part over here on the vertical mill to do the cut the slots and all that, and then I need to make the keys, the brass keys, go in there and then go back over there and do some drilling. I should have milled my keys to size first over on the vertical mill, and then I wouldn't have to tear down my setup that I have and then set it right back up again. To get around that, I've decided I'm going to mill my brass keys over here on the horizontal mill, which is completely doable, completely acceptable. Normally, I would do it on the vertical mill, though. So we're going to get to play around with the horizontal mill, and that is never a bad thing because I love this machine. I love playing with it. So here's what we've got. He sent me a piece of brass. This is the guy that I'm doing the job for. It's this piece he ordered from McMaster Carr. It's way too big, and it's got to be milled to size. It's actually so big that I took it to the bandsaw and I cut it in half, cut it down the center so I wouldn't have quite as much waste here, and we could save some material for another job down the road. So what I want to do is get my horizontal mill set up to do some horizontal milling on this. All right, I think we're about ready to make our first pass here. I just kind of touched off on there. I'm going to raise my table up about 25 thou, and we'll play around with our feeds and speeds. Right now my speed is about 115 RPMs roughly. My feed I've got set on 2 1/8 inch per foot. That first pass there is going to be a little bit uneven just because of the bandsaw cut, so let's let it get down in here to it. Starting to cut there. All right, that actually turned out real nice. I think I'm going to speed my feed rate up a little bit. I'm going to raise it up about another 25 thou. This will be taking a more uniform cut as it comes across. Let that feed on out. I'm looking at the back side here. That finish is excellent, and we do have it completely cleaned up. I'm not going to pull the cutter back across there. That's leaving a little bit of a surface finish that I don't like. So we'll just stop the machine right there, and I'll pull this part out and show you what it looks like. You can see the surface finish there. I'm very happy with that. You know, that's probably nicer than what we would have got over on the vertical mill. All right, let me get it set up to go to the other side, and we'll cut this piece to the proper thickness. Got my material flipped over now. You can see the surface on this. This is a extruded product, so you got this kind of weird looking pattern on there, but it mills right off. I will comment here that I've got about 1/4 inch of grip right now with these particular parallels up underneath here. I'm going to have to mill it all the way down to the vise jaw, which I don't want to do, to get to the proper thickness. So but I like having that little bit extra thickness in there. I got another set of parallels that are an 1/8 inch taller, but that only leaves me an 1/8 inch to grip with. I'm going to wait to the very end and swap those parallels out to get it to that final thickness. But for right now, I want to have that extra gripping power. Let's continue on with our milling. And I'm going to raise the table up another 25. That seems to be working good. It's about 460 thousandths thick right now. We've got to go to 250 thou. So we got a good bit of material to take off of there. Basically, everything that's above the jaw's got to come off. It's going to take a while to do this, but we got time. So let's take our time and get it done. All right, we'll let this feed on through. Well, there we go. We've got it down to 1/4 inch thick, and that turned out real nice finish there. Got a couple little scratch marks in there, probably just from where there's a nick or two in the blade, but that's by no means anything that's going to cause us any problems. So next step here is we've got to cut this width of this down to 9/16. Right now it's about 1 inch 100 thousandths. So we got a little bit of material to cut off of it. I'll probably take a little bit deeper cut here. We're taking a narrower cut, so I think we'll won't have any problem with the chip load. Actually, I think I could have made a pretty hogging cut on this with this horizontal mill. It will really remove a lot of material in a hurry, but without any coolant, I was just kind of trying to take it a little bit easy. So let me make sure that's down, and we'll fire this thing up and continue on getting that thing cut down to the proper thickness now, or yeah, or width rather. Right, I'm gonna just pull that up until it hits, and let's see. I'm gonna do a 50 thousandths depth on this. I think it'll handle it with no problem. So let's just get that cut across. I have flipped this over now, and this is the last rough side that we've got. So we'll go ahead and finish cleaning it up here. Also left it sticking out a little bit long there on the end, and that's just so that I can easily get in here with my calipers and get a measurement on that. So we're about a 1 inch 60 thousandths right now. Got a long way to go. I'm gonna move this over, hit the center of that a little bit better. And tell you what I'm gonna try. We're gonna try a 100 thousandths cut. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 thou. 100 thousandths on this pass. Let's see how she behaves. I came in here and measured this thickness, and I apologize, I can't get my calipers back in there now because I got the indicator set up here. But I need to take 25 more thou off of this. Instead of using my dial on the machine, I've set a dial indicator up here to help dial this last one in, because this is a critical measurement. So we're just gonna raise the table up. That's 10, 20, 25 thou right there. That should be our final measurement. I'm going to let that zip across there, and we should be through and have this milled to the proper thickness or width. I keep saying thickness, it's width. Fairly light pass compared to what we've been making. This should be it. So this is what we started with. Big thick piece of brass or bronze here. This is what he sent me an extra piece here. Don't think I really needed it. At least I hope I don't. We of course cut that in half just so we didn't have quite as much waste. But even still, you can see we went a lot of material to be taken off between that and our final bar here. Anyway, you can see all the brass or bronze here on the table that was waste. I hate to see that material go to waste, but that's what we had to work with, and that's what I worked with. So I've done some measuring. That part is in spec. Everything looks good on it. So I think we're ready to install that over here on the casting. I took my piece of bronze here. I've cut me 2 keys to length and have come over here and tapped these in place. And it was a tight fit. I took a lead hammer, but they just tapped right down in there. Actually a perfect fit, just exactly what I was after. Now what I want to do is drill and tap these so that we can permanently attach them. Not permanently, they'll be removable and can be replaced later on. I'm going to be using this type of a screw here. It's got just a hex on this end. It's a countersunk screw though, and I go down in here. We'll of course make the head go down below flush with the rest of it. This is 1032 is the thread size. I've got a number 21 bit in here, which is the drill size for that tap. I'm going to go ahead and drill through all my holes. Then I'll remove the brass piece. We'll tap into the casting, and then I'll drill these out oversized and countersink them so that those screws will fit right through. So I've got a stop on this so that it will stop at the right depth in that casting. You can see the material change going from the brass to the cast iron. And that is to depth. I'm going to use my digital readout now, move my table over 1 inch. I am trying to make sure exactly in the center and exactly a distance apart there, so that if he has to have some more made in the future, those measurements there are right on the money, since they won't be able to drill both holes at one time. All right, that one is done. Let's go to the other side now. Got a 1032 tap here. That's just a little bit of anchor lube, which is just some to lubricate this tap as it goes down that hole. And normally I like to set up a tap follower to make sure I get these things going exactly straight, but I just don't have enough room on my milling machine. This setup is so high up on the table that I don't have enough room up underneath the headstock to set all that up. So we're just doing it by hand. No big deal. I've already done the first hole there. Let me move this table out where I can get to the other side. I've got the 4 holes tapped now with just a regular starting tap, just a taper tap. So just so you know, the threads are not full form all the way down into the bottom. Because we are going into a blind hole, in other words, there's a hole with a bottom in it, I'm using a bottoming tap to come in behind this. And what that does is it just takes those threads all the way to full form to the bottom of the hole. So we'll just go ahead and run this down and all of them too, and that'll just finish cutting those threads all the way down to the bottom. You can tell I'm getting a lot of turns on this before I bottom out. It's pretty tight. That just shows you how much extra thread cutting that this tap is doing. And I think we hit bottom there. Come on back out. I went over and drilled and countersunk these brass pieces over on my drill press. I'm going to go ahead and get these going in here. I got my screws we're going to use to tighten them down with. I want to make sure that that brass piece is all the way down in there. Just using a lead hammer here to tap it down into the bottom. And we'll tighten these up. I purposely made my countersinks a little bit on the large side just so that they'd be flush with the top there or below flush. All right, let's try it out here. He sent along a extension off of his table saw that actually has the dovetail slot that this slides in. So here's the finished keyways. Put them down on here. And that fits very nicely. Hardly any side-to-side movement at all. So I'm happy with that. So now we can reassemble the fence and get it back to our individual we're doing this for. I think it's all back together. Let's see if we can put it all over here onto the fence. So the bronze keys line up with the holes there. If you remember on the bottom down here, there was a dovetail piece that slides up into this dovetail slot. There it goes. You can tighten this down. That draws the dovetail in, and then using the fine adjust, you can adjust the fence. And if you want to move the fence coarsely, you loosen it up, and the whole fence slides. And that's it. Well, guys, that will be a wrap. I'm going to get back in touch with Lee over at Georgia Craft, who sent this down to me to work on. Let him know we got it all done. He can make a trip back down here to Tifton to pick it up and hopefully get her put back to use. Hope you enjoyed that little series. It's a fun little project to work on, something a little bit unique, something a little bit different that I normally get a chance to do, and I enjoyed the project. Hope you did too. Guys, as always, thanks for watching. Please subscribe to the channel if you haven't already. Comments are appreciated, as are those thumbs ups on the videos. And with that, we'll catch you on the next video. Thanks for watching.